Hello again. Welcome to Optimize 21. Hopefully you've been enjoying some great sessions where the industrial AI vision is being explained. In this session, I'm going to be providing you a demonstration of Aspen OptiPlant 3D layout. My name is Sonali Singh. Let's get started. AspenTech acquired OptiPlant in December of 2020. With V12.1, we are releasing Aspen OptiPlant 3D layout. This is a tool that empowers users to interactively and rapidly develop conceptual layouts. So in the next 15-20 minutes, I'm going to walk you through a demonstration of how to build a layout from scratch in OptiPlant. So here you see Aspen OptiPlant 3D layout opened up in a top view. OptiPlant has been designed as a very easy to use non-CAD tool to develop 3D models. So you can see it's been opened up in a top view with a grid that's set to 200 feet by 200 feet. So let's start developing our model. So on the right-hand side is our library of parametric pre-assembled equipment and structures. We're going to choose a pipe rack, we're going to click on the grid, and for every object on the right, there's a form that pops up and it's pre-populated with data. The user can change the values as they need to. It's basic dimensions like the width and height of the pipe rack. You can also set member sizes for each column and beam. We can choose the number of levels on the pipe rack, and you can set the elevation at the top of steel. So again, very easy to use. Update as much information that you have, and for the rest, you can keep the default for now and come back and change it later. One of the rules is to set whether the level is meant for process, utility, or common pipe. So we've built a pipe rack, and it's been set in the top view here. Similarly for equipment, we've chosen a horizontal heat exchanger. The primary dimensions there are just diameter and length. As you change those values, all the secondary dimensions or the parametrics auto-calculate and change themselves. And you set a location, you can set a weight, and then of course assign a color. OptiPlant provides various tools to copy the equipment, move the equipment, rotate and mirror the equipment. Here are the objects in a 3D view, and you can see we've also set a bracing pattern to the pipe rack. One of the features is to import any existing 2D plot plan data that you might have. So in this case, we're importing in a 2D DXF file, which makes it easier for the user to kind of just place objects on top of the 2D referenced in file. The other key feature here is the ability to auto-create models from Excel files. So here we've imported in equipment from Excel. You can also import in roads and secondary platforms. This data can come from multiple sources and is a really powerful feature to rapidly develop a 3D model. One of the unique features here in OptiPlant is to check your equipment spacing. So each equipment or structure has a category that you assign. By default, these are PIP spacing guidelines. And once these categories are set, the user can automatically check whether they're meeting or in compliance with these spacing requirements. So as I move this pump closer to the tower, I get a notification that I'm violating the spacing rules. But let's see if we can take a look at that closer. So now I can hit Show Violations and choose the pump, and now visually it's going to show me on the screen the yellow area that I need to stay out of against this flammable stripper column. So you can see it's a very easy way for the user to identify whether they've met their requirements or not. So now that we've got the model, Let's go ahead and start adding piping as the next discipline. So within OptiPlant, the data to drive the automatic 3D pipe router is called a line list. Here we're opening up the line list template and just setting some initial units for pressure, temperature, and the size of the pipe. The template opens up blank, and it does allow the user to manually enter in any data, especially if you're just working off of, say, paper PFDs or paper PNIDs. So the data here is essentially a unique ID, a sequence number for the pipe, a size, and the key information is where the pipe starts and where the pipe ends. And we use something called rule-based nozzles. So the user just has to indicate what the relative connection is on the equipment, and OptiPlant will automatically locate that nozzle. If you have digital data in Excel or from SmartPlant PNID, we can import that data so you can rapidly develop this line list. We're going to go ahead and now auto route those 74 lines. This normally takes about 2 to 3 minutes on a standard laptop. Once the pipe has come into the model, the user can review it. And here we've also included the auto routing of cable tray, which you can see on the top levels of the pipe rack. Once the piping has come into the model, the user can automatically calculate the nozzles, and OptiPlant will auto-model 3D nozzles on the equipment. The user now has control over those and can move them around so the pipe would reroute to a new location based on the user-defined nozzle. Now what we're going to show you is how to add a piping assembly into an auto-routed pipe. So in this case, we're going to insert a control valve station into this pipe. Once you choose the line number, you get a similar parametric type form where you can choose the type of control valve station, put in some basic dimensions for the overall station, and things like where you want the isolation valve. Once you choose that and locate it roughly on the pipe, you can insert the valve station, and all of the extra pipes, fittings, and valving get inserted into the model automatically. So it's a very quick way to add additional detail on that pipe for quantity purposes, but also to really validate that there's enough space in this layout to fit these control valve stations. Now that we've completed the piping, let's move on to look at foundations. So we've got our equipment and structures arranged, we've got our piping and cable tray auto-routed. So now we're going to go and add foundations into this model. When we set the pipe racks, we assigned a member size, so OptiPlant knows the overall weight of the structures, and it got input for weight of the equipment. Based on soils data that the user has to set, the user can now come in and choose whether to calculate piles or shallow square spread footing. The foundations are calculated automatically and built as 3D objects here into the model. The user can now view these. They can also select each equipment or structure and get the data around the foundations. So although it's been auto-calculated, the user now has full control or full flexibility to modify this design, update it, and it will update automatically in the 3D model. So once we've completed the foundations here, for all of the disciplines, pipe, electrical, steel, concrete, the user can generate NTOs or bulk quantity reports into an Excel file. So here we're going to look at an example of one of those files. This is the foundation NTO, and these Excel files can then be taken to Aspen Capital Cost Estimator or to other costing systems. The next feature here that we're going to look at is modularization. So let's choose this structure here on the top right-hand corner of the plot plan. So we've just used a fence to choose a group of objects in that area. Then you can say design module. OptiPlant will automatically understand everything that's within that fence. So you're going to name this module. It's going to pick up all the equipment and all the structures that are inside that fence. You can now interactively go through and either remove or add additional objects into that module. So you're further refining exactly what you want in the module. The module itself can be visualized with a bounding box around all the objects that you can see on the screen. Now, OptiPlant has also auto-calculated the total equipment weight, the structure weight, and now it will calculate the pipe weight specific to that boundary of the module. There are rules built in for the location and transportation mechanisms. These are all configurable by the user in an Excel file. We'll also calculate center of gravity and generate quantities by module. Finally, there's a validation feature where you can review how your module is sized for overall dimensions and weight and what is allowed against those transportation logistics. So it really gives the user an opportunity to start designing modules early and optimizing them and ensuring that they're going to meet logistics requirements. At any point, you can also visualize this and open the form again, so it becomes a great collaboration tool specific to modules. All right, now we've developed our 3D model, and we're going to go ahead and talk a little bit about the integration to Aspen Capital Cost Estimator, or ACCE, and how you can take the data to ACCE as well as to Insights. So the first step here is that the layout itself, the equipment arrangement and the structural arrangement, can be exported to an Excel file. And this is an example of what that Excel file looks like. This is the file that we will publish to ACCE. So directly from OptiPlant, there's a button to export the data to ACCE. You're just going to choose the data set. So in this case, we've chosen the entire layout, and you're going to publish it to the ACCE API file. And as part of this integration, we've already done a lot of the mapping around equipment symbol shapes, around equipment worksheets, so you can, of course, update that. So here within the API file, we can see the group of heat exchangers from OptiPlant. The data has been published here for the equipment footprint, the equipment coordinates, as well as for the symbol shape. Now we're going to do the same approach with piping. So in this case, you're going to first generate the piping MTO. OptiPlant provides a lot of flexibility in how you want to generate this. So you could choose to just generate quantities for the on-rack piping and use the ACCE volumetric quantities, or you can choose to generate by area or all of the pipe MTO. Similar to the other report, this gets saved to an Excel file. But it really does give the user and, say, the estimator control and flexibility over how they want the data, or what data they want to exchange between the two systems. Now we go back to the ACE menu, and this time we're going to choose the piping quantity. There's a couple of ways this file can be written, either as a single pipe entry or associated to equipment. And we'll show you both as part of the result here. And again, we've done the mapping for pipe materials. You can set item descriptions and parent areas so they match how you set up your project in ACCE. So once this is published, we can just take a look at the file. This is the line-wise report, so you're going to see each line number, and then associated with each line number, you'll get the material, the quantity of pipe, the size, as well as inline fittings. So number of elbows and branch connections, valves, pressures, temperatures, whatever data is available in OptiPlant, we can push that data back here to ACCE. And for the pipe rack quantities, of course, we can associate those as well. This is the equipment-wise report. So here you can see the pipe is associated to the equipment tag, and the quantities are automatically split between the two equipment that is associated to. And in this case, again, the on-rack piping can be separated out into a different file. So again, there's a lot of flexibility in controlling this data exchange based on what data should come from OptiPlant and what data you want to leverage from ACCE. Well, I hope that gave you a view or a quick demonstration into how OptiPlant can help you rapidly develop a 3D model. There's definitely other features and functions that we did not cover in this short demo, so I encourage you to please reach out, contact us, and we'd be happy to schedule a more detailed demonstration for you. Thank you for your time today, and I'll be standing by to answer any questions that you may have.